doing this afternoon? I need to start asking a quick question. How many of you use C#? Raise your hands high enough I kind of get an idea. Great. Okay, because I didn't know whether I needed to do a little bit more remedial when I got to the C# stuff. I'll show, I think, just enough to be a hint for those of you that may be here because you know functional programming as opposed to C#. All right, so this is something I love to talk about, but I'm always evolving my thinking. And as such, I've rewritten my talk in the last 3 days, partially because of the great conversations I was having with people here, including Tuesday night with Kathleen at a meetup. Were any of you at that meetup Tuesday night? Great, thank you for coming. So this is my abstract. Show you there for a minute to make sure you're in the right tent. And there's an unusual word in here, which is winsome. What does winsome mean? It means it's attractive. Functional is very attractive to us right now. And part of what this talk is about is helping you to understand why, what the alert is, and how it can actually help you, as opposed to just being a fashion statement. This isn't like the dress length or something of that kind of fashion. This is something that actually makes sense like pockets. So we're going to talk about that. And that's also a shout out to my favorite blues musician, Chris Smither. And so Chris has been on the road playing music for 60 years and is a great inspiration to me. And so I thought I would throw out, if you like American blues, then you will be, I think you will enjoy Chris. Let's start with what is a functional language? Oh my gosh, shall we start there? Well, a functional language has a central concept of being a function. When you start up, you run a function. An object-oriented language, the central feature is a class. The first thing you do is to instantiate a class or to reach out and touch a static method inside a class, which is what you do when you start up a console application in Visual Basic or C# or, I believe, Java. Are there any Java developers here? Okay, so I will just warn you, my Java is bad, so I'm not actually going to try to talk about Java, but Java is going to follow most of what I'm talking about. Okay, that's where we're going. Now, in a functional language, functions are first-class citizens, and we'll talk more about what that means. And in object orientation, they may or may not be. They are in C#, which is why we can do the fun things we're going to do. There are far bigger distinctions, and we tend right now to have a conversation. Well, are you functional or object-oriented? Well, those two things work very well together, and the answer is yes for many people, and I hope for more of you after this talk. There are some distinctions that are at odds with each other, and I'll run through a couple of those quickly, one of which is dynamic versus strong or static typing. There are a few crossover ideas and a few crossover places like Visual Basic, but in general, you're in one world or the other. Another is how intense your compiler is. If your compiler is very, very strict, tells you you must do things correctly, that's very different than a world like JavaScript, where it's just like, yeah, whatever you want to do is fine with me. I figure you know what you're doing. And that's what happens when you're inside a language that does not have a compiler that's very strict and polices you. Compiled versus interpreted. So if you're in something like C# and you're compiled, then you know, as a developer, you know where your problems are up front. You get to know earlier. You don't have to run the code the way you do in an interpreted language. And then there's one that isn't actually about the language, but it's very important to how you work with the language, and we're kind of halfway there in C#. We can't decide. So, and that's whether there's a REPL. So a REPL is something where you type in code and immediately executes. So there is a REPL in F#, and there is a REPL for C#. It's just not quite sure what Microsoft is going to do with that. So if you use the REPL and you think it's a great idea, you should probably let us know, because right now it's there, it's still available. I don't think we're going to take it away, but it's not deeply embedded into .NET Core. So that's where we start from. Now, one of the things that I have been talking about this week most intensely, because of the people I've had a chance to interact with at this great conference that has a lot to do with who you are and how you act as a programmer, is to think about culture. And culture is important because it's how we communicate, of course. But it's also important because culture drives how you think. When you use words, those words drive your thinking. And so as we look at functional concepts and you go out of here with a deeper commitment to a few concepts that we're focused on and some other ideas, then you're going to have a broader ability to affect the culture in your organization at the speed that organization can take it. This is one of the beautiful things about C# and doing functional in C#. If you've seen any of Linda Rising's work, she's going to do the closing keynote, and it's going to be, I believe, on this subject. You cannot change a complex system by walking up to it and slapping it around. It doesn't work. You have to change a complex system by changing something that then leads to a ripple effect very slowly over time. So you probe the system and you change some things. So when I talk to you about something like testing, this is not just important for the sake of testing, but it's a way to probe into that and start moving you towards being functional. So you will not go out of here saying, I'm going to rewrite my application, or at least I hope not. Okay? I hope you go out of here going, you know what, I can tweak this. When we start this part of the application, we can do it a little different. And that's how we make fundamental and lasting change, is to do it by taking what we are already good at and tweaking it so that we become better. When we start over and say, we're going to start over, we don't get there in the same way, which is why I'm so passionate about adding new concepts to the language you're probably already in, which is great because I took a poll and you are. So I was hoping. So that's great. So let's ask a couple more questions before we start looking at the actual technical concepts. One of which is, why do we want to do functional programming? Oh my gosh, why are we doing this? It's cool. It's cool. Yeah, it is cool. But it's actually cool for a reason. Again, it's not the hem. It's not how long the dress is. It's pockets. It's pockets. It's like, this is real, okay? I don't have any pockets here because I had to wear something that was cooler than what I intended to wear. Testability, parallelism, concurrency, reuse, expressiveness, and a word I've come up with this week working with Kathleen, which is reasonableness. Reasonableness does not mean it's reasonable, it's unreasonable, it's crazy, it's not crazy. It means, can I reason about it? Can I take this thing that I'm working on and look at it and reason about what it's going to do? And fundamentally, what will it do when I change it? I can reason about it. That's great and wonderful. There's just one problem with this list. I don't need functional programming for most of it. So, testable, well, that's about purity. We'll talk more about purity. So that's the core thing about how testable your systems are. Parallel, well, that's about immutability. We're not going to talk about immutability today, but that just means your data doesn't change. Reuse, well, we have loads of ways. We've been reusing code. By the time you wrote your second line of code, you were starting to think about code reuse. We do this already. Expressiveness, well, that's just less smelly. We're just looking at ways to make our code smoother and less smelly. And reasonableness is all about craftsmanship. It's all about the things you're already thinking about. So it's naming, it's single responsibility principle, it's short methods, it's all of these kinds of things. So I'm going to say that the fundamental reason to go into functional programming with C#, which this concept, is because it tweaks all of these. You can get better at all of these. And again, like Linda talks about, you can probe into the system and say, for us, purity would be great. That would really help us. Our mocks stink, and I don't want to have to use mocks so often. I want a pure system that's easier to test. Or maybe there's another place that makes sense for you to dive in and get into these ideas. So I say, number one, right there you are. You already use it. That's the number one reason, but it's not the only one. Strong typing is valuable. It helps you reduce accidents, but we don't like to type. We don't want to have to say, or at least I don't want to say customer, blah, equals new customer. I just said customer twice. That doesn't make any sense. So we have type inference, and we have implicit operators in order to help us not have to type so much. We also have generics to reuse types. We'll look at generics quite a bit today, late in the talk. They're fantastic, and they're very well done in C#. We have extension methods to extend types. So if I want to do something to the string type, like I don't understand why we don't have substring after. Substring after has been in many languages. It's not in C#. How annoying. Well, I can just add it. And that's what an extension method allows us to do. If you follow what's going on in Redmond right now, we are working on the things to put on the table for C# 8. There's no announcements of what we will do. There's only a lot of information about what we're thinking about doing. And one of the things we're thinking about doing is something called extension everything, which means that you can make extensions for properties, for operators, for methods, for some static things, and so we're just going to be, and for instance thing, I'm sorry, we do static now, adding instance, so you'll be able to expand the range of how you can walk up to a type, even the string type, and say, I know how to make you better, and you'll be able to do it. So the other thing that we have, functions of first-class citizens, we'll talk about that. Then we have something I'm not going to cover today, which is expressions and expression trees. So I'm going to mention it right now, and then I'll mention it once at one other point in the talk, which is that when we look at a function that is expressed as a lambda, there's other ways to express functions, but if it's expressed as a lambda, we can see it in two different ways. We can see it both as a function, as something we can execute, but we can also see the contents of it, as what's called an expression tree. How many of you took a compiler course or know something about compiler theory, where if I say a syntax tree, you know what I'm talking about? So for all of you, it's more or less a syntax tree. It's more or less the ability to say, here is this tree that describes what I'm going to do in this lambda expression. And that's fundamentally valuable inside the language. And most languages don't have it. It's very special to C#. So we keep the best of this and we add more. So this is, again, why functional. This is why we're going around doing this. And now we're going to talk about purity. So purity is no surprises. Oh, no surprises. That's the point of purity. So we're going to do a little exercise here. It's after lunch. Everybody needs to get kind of going here. So I'm going to open up where'd it go? Where is my pure or impure? There it is. I knew it was here. Okay, so I'm going to do Control-M-O to close everything up. And now what we're going to do is we're going to look at these quickly, and you guys are going to quickly let me know whether you think it's pure or impure. And that way we'll have a good handle on this because code is worth 1,000 words. So, is that pure or impure? Yes, it's pure. The state of the universe is exactly the same before and after that code executes. Nothing in the world changes, and it always sends back the same thing. All right, so now we'll do the next one here. And I don't have my mouse, so I'm a little slow. Come on, you can open up. Come on, there we go. Okay. So is this pure or impure? Loud, tell me loud. Pure. You guys want to do it like this? All right, good. Pure, impure. Impure is not bad, but this is going to be impure, this is going to be pure. Pure, all right, we're pure. Okay, great. Okay, so what about this one? Is that big enough for you? Do you want me to make it bigger? In the back. You want me to make it bigger? You good? No? Everybody's good? Okay, I'm happy to make it bigger. Okay, is this one pure or impure? Okay, show me. Oh, a bunch of you are going impure. Some of you are going pure, some of you are going sideways. Yeah. This is the point of this one. It depends. It depends on how you define purity. Absolutely, definition of purity, this is not pure. Not pure. By the definition, absolutely. But if you think about the way you write code, think of what a pain that would be. It means you can't do logging. Oops, I want to do logging. I want to put a logging statement anywhere I want. I don't want logging to ever get in the way. So purity is something that, yes, it has a definition, but let's make up a definition for each of your organizations, or at least each of your teams. So your team can say, you know what? I want to be able to put debug statements in. And I use WriteLine. I use console.WriteLine or debug.WriteLine, and I use that in my code to debug, and I don't want to change that. Great. You just define purity where you allow that. Same thing with logging. Now, you can't go change a database. That cannot be part of your definition of purity because it's just not. You are clearly changing the state of the universe. But there are a few things around the way we record the actions we're taking, which you can cheat on if you choose to. I kind of suggest it because I kind of like logging. But nobody ever wants me to do a logging talk. They think it's boring. I love logging. All right, let's do another one. Okay, this one. Oops, come on, you can do this. This has kind of stopped working here, so let me Okay. I've got, could you look in my bag, and in the very outside pocket, there is a pen, a surface pen, in the very outside pocket, and that's going to make this easier. My touchpad has stopped working. Okay, is that pure or impure? We just had the conversation. What is it? It's definitely impure. Why is it impure? It has no purpose. This code, thank you. This code does nothing, except change the universe. So even though it does a calculation, it does nothing with it. Okay, so this one is impure. Okay, let's see if we can get this to behave a little bit better. There we go. Okay, how about this one? I got a couple more. How about this one? Pure, impure. Everybody's going impure, right? We got that one? Impure, totally. Because every time we run it, we get something different back. Okay, now we'll go this one. Okay, is this one pure or impure? You're not answering. You're saying kind of, but it's not really kind of, is it? It's like, it depends. We're consultants here, it depends. So the answer is now you can state that now you know that it's pure. So to be pure, method has to be pure, everything it calls. So now, you've been seeing this comment down there, I hope, and have been thinking about this. What about exceptions? What about try-catch? How does that relate to purity? So let's start with this one. That has a try-catch in it. Is that a pure method or not? Pure or not pure? You think it's not pure? You think it's pure? Lots of pures. Let's do a little bit sideways. Okay. So let's take a look at what happens. So we have division, which can clearly fail. If y is 0, this fails. Okay? So because they're integers, y is 0, we're going to fail. Okay, so it's going to throw an exception, but the exception is going to immediately be caught and swallowed, and 0 is going to be returned. So this is a fully pure method. So sometimes people say things like, you can't use exceptions. Truth is, you have to handle exceptions to make things properly pure. And for us, this is a huge question. It's something you have to think about in your teams as you're seeing what purity is going to mean, because that is not pure. That is not pure. What happens when y is 0? You have absolutely no idea. You know what this method does. This method throws an exception out in the universe, and you have absolutely no idea who, where catches that exception, if anybody. So it can't be pure, because you don't know what happens next. So this is not pure. And so when we talk about scopes of purity, this exceptional behavior, things that shouldn't happen, you need to define the scope for that. Because if you don't want to put try-catch in every method you ever write, oh my gosh, that would be a real pain. So one simple way to do it, if you want a simple rule, is to say if it's private, it does not need an internal error exception handling, and otherwise it does. That's a very strong, that's like, we're going to catch it. We're going to catch it in this class all the time, okay? So one way you can do it. I'll talk about a little bit broader boundaries that you can work with for exceptions. Okay, so purity, we're going to kind of talk about that a good bit. Okay, so we did the demo. No surprises. Control flow should be predictable. Void methods, unless they're so stupid they do absolutely nothing, are always not pure. Pure code is easy to test. You give it something, you get something back. So again, be clear within your project, what world cannot be changed, and the same thing must always be returned, what that means. Now, purity is totally boring. Totally boring. Now, have any of you written in Haskell? Haskell was created by committee of mathematicians. You should be scared from the beginning. But it was created not as a language to code in, but as a language to do mathematical papers in. So it sat in language for over 10 years because you could do nothing with it. You couldn't write to the console with it. It allowed nothing that wasn't pure. And then they came along and they said, we know how to solve that. And this is what happens to a Haskell program. In order to be pure, the Haskell program says, darn it, I can't write to the console. I can't do that. But I really, really, really wish someone would. Sorry about that. Cut the mic for just a second. So, get me back. Sorry about that. That was a bad coughing fit right in the middle there. Haskell says, I really, really wish somebody would on my behalf. And so there's something called a monad that sits on the edge, and that does that for the Haskell program. And that's why Haskell is challenging to write in, because you have to write your whole program and then talk to the outside world. And we'll talk about how C# is different. So for a lot of our programs, this is more or less what we do. I want to simplify everything else in our universe for a second. More or less, we have a customer. More or less, we have data. That's our universe. Okay, so we have a pure functional world, and then we put a wrapper on it like an orange. Inside is the good part, and outside is the band, it's the stuff. But you sometimes need it. If you're making a cake, you need the orange peel. If you're taking your orange from home to work, you need the orange peel. So there's time you need the outside, but it's not the soft, good, squishy stuff. So we can talk back and forth across this boundary, and that's code that is not pure, and that's fine. So we want to separate pure and not pure code, and we're going to use this as a little graphic for that. So C# loves functional techniques because it's very good at this. It's very, very good at this. So you can have functional islands, and this is the way you probe your code, and you make it a little bit better and a little bit better, is that you don't have to sit out and say, my next program that we write, the next application, will be functional programming in C#, or F#, or Haskell, or whatever you're doing. You can say, hey, you know this feature, whatever it is, we would like to make that more functional. Let's find boundaries that we can create these pure islands in. All right, so why? One of the reasons is this. Testing matters. I don't want to tell you not to test. However, quality is the smallest reason I personally care about it. Before I joined Microsoft, I was the director of engineering for a small software company. Before that, I was a consultant with many organizations. And the way to measure sanity is whether you can test. If you can't test, you probably have a crazy app. If you can test, you probably have a well-designed, architectural, created app. So we use a little graphic again. So you can unit test within the pure limits, and you can do automated functional testing across the boundaries. That's awesome. Don't mingle pure and impure code. We already said that. Also, don't mingle unit tests with functional tests, which is incredibly confusing because we choose to have a tool, or someone else did it for us, where we do all of our automated testing, functional or not, using a tool called unit testing. NUnit, XUnit, it's a unit test tool, okay? But it can't be a true unit test if you have to use a mock to make it work. It's not actually testing a unit. What it's doing is saying, I have a world, I was talking to a database. I can't test that very well. What you're doing is you're forcing a pure boundary. You're saying, I'm going to put a mock right there. When I put a mock right there, when it starts to go out of my pure world, it's going to come back in. And so I'm never going to get out of my pure world. Mocks are a way to force purity onto your system in order to test it. Mocks are also a pain in the neck to do. Sure, you need mocks for your functional flow, for your functional tests, but get them out of your unit tests and design where you don't need them there. All right, separate not pure code. Did I say this already? Did I already say that? I think I said that. So I said that. Okay, that's important. All right, now, I gave C# grades. This is totally my opinion and nothing else. Okay, that's all this is. So these are things that, in my opinion, C# does well or not well. And so as you look at ways you're going to approach functional techniques inside C#, I think it's helpful. I don't care if you agree with my grades or give it something different. I think it's fantastic, though, if you know, you know what? When it comes to first-class functions, I think we got it. Okay? When it comes to purity, we're going to have to work hard. We have to establish some stuff there. Immutability turns out that it's pretty good on a class, not totally good on collections and lists. That's why mutability gets a B-, OOP, etc. Strong typing, we know it's good at that. Pattern matching right now, it's got a cool little new pattern matching feature in C# 7. I get confused by the numbers. There's so many of them. Which is hysterical, because there's one set of numbers that's my problem. I actually decided it. Not 7, though. But pattern matching is done as a statement in C# right now. which if you're a functional programmer, you're kind of looking at that going, what were they thinking? Why did they do it first as a statement? And it's consistent with C# generally, and it made pattern matching immediately valuable to C# customers. To all the people that write in C#, all of you can immediately use pattern matching. It makes an if statement that's comparing to a type so much prettier. But what we really want to see is that as an expression. So we can stick it into a functional stream and use it that way, and that's also on the table for C# 8. And it just doesn't do records or duck typing. Functions first-class citizens, we define functions like data, we support higher-order functions, all this is good, C# and Visual Basic, it means delegates. So this is the part that I'm going, I guess it's, yeah, this is my time. That's what I've got left? Really? Oh my gosh. All right, we're gonna go fast through this. We're gonna skip something here, okay. So, generic, blah, blah, blah. You got it, okay. We use lambdas, okay? We're almost always using lambdas. Don't forget about the referencing a method without its parentheses, particularly with local methods, because it allows you to name your lambdas effectively, and if you have a performance concern, it gets you around the performance problem. Blah, we're done. Okay, all those things mean the same. We're gonna go through a couple slides real quick, and I'm just gonna get here. Oops, I wanna get here. Okay, so what I do normally is people look at this one, and they go, oh my gosh, my head hurts, my eyes are burning, oh my gosh, what have you done to me? There's lasers. And then I show you this one, and I hope you say, you know what, I can handle that. All this is an async that returns a result. I'll talk a little bit more about results. Okay, returns a result. The result happens to be a list of student. Okay, this is just a review of lambda expressions. Most of you probably have this. The point is, unless there is one parameter being passed, you need to use the parentheses. That's the point of this slide. Just in case people weren't. I'm going to skip link on the assumption you kind of know link. Most of you are using C#, so the fact why we care about these delegates is probably not something I need to worry about. Action delegates are a problem. So delegates come in the form of actions and funcs. Again, I'm going to slide through this because there's stuff more interesting later. But the problem is I want you to kill action. I want you to murder it. Ugh. Okay, and the reason is that when we have action, it's about like func. It's not going to be pure, which is part of the problem. The bigger problem is it doesn't exchange with func. So I have a whole bunch of methods that take whatever the function is. And this is, you know, I'm just going to record the time while this runs. I need you to give me a func to do that. I'm going to let you give me 1, 2, 3, 4 parameters. Kind of get your head around what that might do. I got to write another set for action. That's really annoying. So, in the number of there is called arity. So this is in the code that I'll put up so you can look at, and it's also here on the slide so you can look at. So you can change functions, you can change delegates from one type to another. And when you do that, one of the reasons I want to show this slide is I want you to understand that there's nothing fixed about the way a delegate behaves. It can change. And here we're changing something from an action to a func, and it requires that we use a type that doesn't exist. I'm calling it a void type, and there's a couple ways to do that. And I'm not going to go through details on this right now, but if you think about it for a second, you can say that a method returns void, and that is a keyword. It doesn't actually mean anything. You can say something returns null, but that's not a type. We don't have a way to say, hey, nothing's ever going to be here. And that's what the void type does. Errors, what could possibly go wrong? I want you to just take a quick look at this. We're not going to talk about it in detail, but I believe we make a mistake quite often, there we go, quite often when we're planning our systems, and that we think something could go wrong, tell me something when it goes wrong. Give me an HTTP error code. Always give me an HTTP error code. But then we start looking at HTTP error codes, and you guys, if we were to set up the right situation, you guys would all but wrestle and beat each other up over certain HTTP error codes. When you use a 500, when you use a 504, 504, 505, 505, when you use a 505, when you use a 500. And this is just silly. So if we back off of all of that and we say we need rich ways to express what we're doing, and the path to that is different. Okay, so I've got up there, I've got anticipated environmental issues like database missing. It goes in the event log on your server. It goes some way that it's going to go ping somebody in ops to turn the server on. Okay? The ops people don't want to hear about they may want to hear about your exceptions, but they're not going to do anything about it, and you don't want to hear the servers down. So we do different things with it. We need a lot of richness. The best way to do that, in my opinion, is to have some sort of result you pass, at least between layers, at least in and out of your functional boundaries. I'm going to show this. I think I have time to show this. Okay, so let's just look at this. So my data result is here. Now it's working again. That's awesome. But I'm still going to, come on. I'm sure it's just like, oh, I'm so sweaty, it's so hot. Okay, so what we've got is a base class that understands success and understands error, and that can be infinitely rich. Whatever inherits from error base can be infinitely rich. Let's keep it simple right now. Let's say that there was an exception happened or a validation error. Those are fundamentally different things. And then you can add a few more, like ops cares, dev cares. We're going to tell the user what the problem was. We're not going to tell the user what the problem was. There's a lot of richness. We're going to localize. We're going to localize into the language for ops. There's a lot of richness can sit behind this. Infinite, whatever you need. And it can evolve. Once you do it this way, you can start with something that's maybe as simple as this. And then you get you're going, and before you get into production, you get something moderately complex. And as you have problems and you need more information, you do things like have a GUID that points to some particular location in your logging stream. You can add those things very gracefully because you have a place to work with to do it. You have an abstraction for that. Okay, so we've got that. And then if we go back to no, I want to go here. I just want to roll down on this a little bit. To the result, we've got the base result, and then we have a result that is of data, and then we use our void type again so that it's easier for us to interchange these, for them to be polymorphic later. And so we have a way to carry data along. But we also have the acknowledgement that we don't always need data. Sometimes the only thing we need is whether it's succeeded or failed. For example, if we're updating a database, that may be all we need. So results are extremely powerful. I have used them for years and love them and think it's a great way to work. Okay. Now what I want to do is stretch your brains just a little bit. It's after lunch. It's very hot. And what I want to do now is look at refactoring in a functional manner, and I'm going to talk about something called outside-in and inside-out refactoring. You know inside-out refactoring. You do this all the time. You say, grab some code, put it in a new method, use it. That's very simple. I tried to draw a graphic of this. I love PowerPoint. So we want to do something with that code. That code we want to reuse. So what we're going to do is we're going to pull it out. We're going to take the code around it. This on the right is our new state. And we're going to say, yep, just call the new code. Pretty straightforward, and you do it all the time. You do it so much, I'm not even going to do a demo of it, okay? Because this is what happens when you say extract method, okay? C#, even Visual Studio without ReSharper does this for you. Okay, we're not going to do that demo. Outside-in refactoring. And I hope I have a chance to finish this demo. If not, if it goes wrong in any way, I'm going to quit and then let you do it on your own, which I know you can. So inside-out refactoring. So what we've got here, oops, I got to get rid of foo. Foo doesn't even compile right now. Let's get rid of that. Okay, so what we're going to do is we're just going to do it on the small part. We're going to do it on the try, okay? So we're going to start by taking this whole method, the whole thing. There we go. It's interesting to do it with a partially working mouse. There we go. Okay, so we've got this, we've got a new one. They're going to conflict, but we don't care because we're going to fix that in just a second. Okay, so what we want to do is we want to say, okay, this isn't what I want to pass in. I want to pass in what the try is actually going to be all about. So I'm going to say it's going to be a func, okay, and this func is going to take nothing, and it's going to take nothing, and it's going to return an int in this case. I could change that to t, but for time I'm not going to. And that's the operation we want to perform. And then I'm also going to do a func of, wait, why am I not getting func? Hang on. Have I lost my mind here? If anybody sees a problem I've obviously completely lost my mind, and I have numerous languages in my head. Is that just a using system? What have I done here? Using system. I was going, okay, that really looks like C# code to me. There's a lot of languages in my head, so I can mess up, but I don't think I have. Okay, so here we need func again, and we're going to say func. Obviously, I have a namespace named functional. And here I'm going to say, give me an exception, okay, and tell me what to do when that happens. So I'm going to, you're going to have a it's going to take an exception, and it's going to return a void, I bet. It's going to return a result in the end, but we're just going to put a void type in here right now to get the general idea of what we're going. And then we need the angle, and we're going to say catch. Okay? So now what we're going to do is we're going to take all of this and we're going to kill it. We're going to kill. We're going to kill this code right here, dead. And we're going to just say op. I forgot we have to say catch op, or we have to put that at sign in front of it, which I hate doing. So we're going to say op, and then we're going to say just do it, okay? And we're going to return that. This should have returned, this is going to just return an int, take nothing, and this is also going to have to return an int. So there we go. All right, there we go. You guys were ahead of me on that, I hope. If not, that's okay. So we're going to say, kill this. Well, let's just kill it anyway. Catch, and we're going to do the catch op. We're going to pass in an exception, which we're going to add, which we don't have, and then we're going to do whatever the catch op is. Again, we're going to return that because it returns an integer like we need. We're missing a close curly, and here we're going to do the same thing. We're going to say return. And now, if I can spell, we should have working code right there. Now, what I'm going to skip right now, I apologize for, because I would love to have time to do it, but the call to this just takes that code and puts it into a Lambda expression, but I'm going to skip that right now. This is extremely powerful in taking this right here, just handling try catches. It allows you to, remember I said earlier that you want to control the scope of where your exceptions go. So one of the ways to do that is to have many of your methods have a try catch within them. That's a lot of try catches to write. And what's worse is that's a lot of catch behavior that should be the same for everybody that you're going to have to keep up with. So if you wrap everything in a try, like this, you just call this little, it's not called foo anymore, now it's called try, with a capital T. You wrap everything in a little method like this try, then you're going to be able to change your behavior on catch more easily because you can, instead of passing the catch behavior in, you can hard code it in here. Okay? I was a little bit fast through that, I apologize. It is going to be in the samples. And so outside in refactoring is like this, and we're going to take the outside code, that's what we care about, we're going to put it into a new method, we're going to take the inside code, we're going to put it into a Lambda expression, and then we're going to call it. All right. So we did that. So, oops, wait. Okay, so as we close up, what I want to look at is how you can actually use this in your applications, okay? So the first and very important thing is we have to tie up something about the talk, because I have not shown you a cloud, a cat, or an active GIF yet. I've done none of those things so far in the talk, and there you go, all three of them right there with our cats opening and closing their eyes. So we probably have our data in the cloud. Now, for your application, these islands have specific functions. One of them is validation. So you can validate, and then you can end early and pass back a result that has validation data in it. You can also have some business logic. You can also have map entity to domain or something else where you're doing a shift. Now, this line right here, in a perfect world, looks the same for all of your applications. And I don't mean kind of the same. I mean exactly the same. You won't get to that perfect world for a long time. But what you call that arrow through the middle is architecture. What you call these things jumping out is your application. This splits those two things apart. So if we take a quick look at one important thing on that, we're going to look at generic inheritance hierarchies to do, in a way, it's something called partial applications in the functional world. I won't explain that, but I will explain this because this is so powerful. I thought I had one more thing there. So the base class has no generic type, the leaf class has all the types, and in between we keep adding more types. This is what it looks like. So we have a course repository, it's about courses at a university. Okay, and it actually has a course class. It's very specific, very, very specific. It understands keys, it understands the columns, it understands the properties, it understands everything it needs to know. So we have that. And then we have a base entity framework repository in this stack. So this understands the entity framework. So it understands what a DB context is. And it's the implementation of everything except mapping. And then we have a base mapped repository. And a base mapped repository, and you're going, oh my gosh, this is tall. It understands an abstract get. It understands these things in an abstract sense. And this is very valuable because it understands the concept of an entity. And in this case, there is a mapping between the entity and the domain. And it understands that that exists, okay? And so then we go up to the last one, a base repository of the T domain and TP key, okay? Anyway, why is it so tall in particular? What about the second and third one? Why is that there? And the answer is that you can map to other things. And we found it extremely valuable during development to map to JSON. Come on, you can do it. We mapped to JSON right there. So we didn't need a database to do development and to put UIs in front of our customers, in front of people. This is when I was working on the outside, not at Microsoft. We didn't need that. We could go ahead and get it out. Coming back to our cats, coming back to the end, that is time for questions. I have gone over by a little bit, but can I still take a question or two? Do you have some?
I think
do you have any questions? Do we have time?
Do we have time for questions, right? Yes, we do. All right.
We do? Okay, questions. Great. Okay.
There we go.
Oh, great. Okay, so let's see what we've got here. I'm sorry, I didn't have more time for this? Okay. You know what? I will say that first quote. Okay, you guys can read it, so I won't reread it. Great, I don't have to repeat the question, that one. I have heard those words exactly come out of Anders Hallsberg. So there are people that think that. I would say most of the team doesn't really think that. They believe what I'm sharing with you, which is that functional techniques make C# better. And actually, Anders does believe that. It's just there comes some point out there that he's not sure we should cross. But we haven't found that point yet. We're putting a expression match in. Okay. How to handle the CLR exceptions, impurity. You have to get them out of being exceptions. I mean, that's just, it just isn't going to do that. Why is the current second not pure? I have to look back and what that, it does, probably, I don't know exactly where we're going there. That one, I don't have enough context of that. And when definitely to go functional, you mean all the way functional? I would say that the reason to go fully functional is actually when you have a very complex parallel operation that is going to have more calculations than it does things like data flow, and then something like Haskell can be your great friend. The other place to do it is in a web browser, because you're in JavaScript there, and that's a fully functional language, so you might as well. Mocks for everybody. I hate mocks. I'm sorry. That's just a really personal thing. I use them, but I think they're the point of last resort. Oh, no, you need them. Okay, the idea is that what you want to do is get as much of your application tested before you go to a mock. And then remember that big black arrow I called you architecture? That's where the mocks do belong. You're going to want to mock there. So it's not that you never use a mock. It's just that you drop back to not needing them very often. And I'll give you a specific example of that. Have you ever tried to mock and had 100 different values you were trying to mock? And you were trying to do all sorts of different combinations and stuff? That means you're trying to test your logic, not just your flow. Your flow is pretty straightforward. You only need a couple of mocks to do that, only a couple of sets of values to do that. And with that, I think I'm going to have to stop. I do this all day. I love this. Catch me later.
Thank you so much, Kathleen.
Thank you.
Thank you.
Thank you.
Thank you.